All right, let's look at another question. 2017 AMC10B problem 20. The number 21 factorial is a large number, has over 60,000 positive integer divisors. One of them is chosen at random. What is the probability that it is odd? You can pause the video and think about this question. Okay, so before we solve this question, we're going to review some number theory stuff. So if a number n, that can be always write a factorized prime factorization form. So let's say this is p1 to power k1, that's the first prime, times p2 to power of k2, etc. to pn to power kn, right? So we know the number of divisor, we can denote here the number of divisor dn. We can write actually the power k1 plus 1 parentheses times k2 plus 1 times etc. kn plus 1 to power plus 1, right? Okay, so I just give example 24 using 24. 24 equal to 2 to the power 3 times 3 to the power 1. So the number of divisor of 24, d24, actually equal to 3 plus 1 times 1, this 1 plus 1. So actually this equal to 4 plus 2, that's actually equal to 8. So there's 8 divisors, right? So why there's 8 divisors, right? So I'm going to give an explanation here. So, you know, the divisor of 24 must be made by either factor 2 or 3, right? So we can think about, we're going to pick about a 2 or factor 3. This will be 2 steps. So how many ways we can pick about factor 2? So we can have 0 factor prime factor 2, 1 prime factor 2, 2 prime factor 2, or 3 factor 2, right? So let's see. If I got 3 factor 2, that's 2 to the power 3. So then I'm going to times factor 3. So for factor 3, I can have choice 0, no factor 3, or just 1 factor 3. We can have no more. So we have 2 choice. If I have 0, 3, that's 3 to the power 0. So we can see we can have a factor 8, right? Of course, if we have 2 to the power 3 times 3 to the power 1, that will be 24. So we made these 2 factors, right? So this just like how many ways we can make the factor. So this just a 2-step, right? So the first step, we have actually 4 choices. So the top degree is 3, but we have another choice 0. So that's how 3 plus 1 come, right? So and also this 1 plus 1, because the highest degree is 1, we can also have 0 factor 3. So that's basically 2 to the power 0 times 3 to the power 0. That's equal to 1. That's always be a factor of n, right? So that's how count how many divisors. Okay, with this, so we're going to look at this question. 21 factorials. We can do prime factorization. That's going to be 2 to the power of, yes, how to find 2 to the power what? 2 to the power k times some 3 to the power something, right? K, we call k1, k2, then we have 5 to the power, etc., right? k3, etc. All right, so what is k1? Right, so the k1 can be found out by this. So 21 divided by 2, then plus 21 divided by 4, plus 21 divided by 8, plus 21 divided by 16. There are no more. So this is a 10 plus 5 plus this is 2 plus 1. So this equal to 18, right? So this 21 factorial actually equal to 2 to the power 18 times the rest. So that's all factors. We can see there are going to be 3 to the power k1, 5 to the power k2, k2. So 3 to the power k2, 5 to the power 3, etc. Right? Then how many factors are there? Yeah, if we want to find exactly how many factors, we're going to find the number of 5, factor of 5, number of factor of 3, etc. Right? Okay, but actually we just need to find the probability of the factor be odd. So now we think about how to make a factor be odd. So let's see, we just look at being odd. So we're going to have no factor 2. So 2 to the power 0 times the rest of the odd factors, right? So we can see there's maybe there are m ways to drop in the factor 3, 5, and all the prime factors here. So let's just see m ways, right? But we could not just on 2 to the power 0. We can pick up 2 to the power 1 times the m ways. That's make a factor. That's all even, right? So we can have other ways to make factors. 2 to the power 2 all the way to the power 18. So each of these have m ways. So you can see that's just equal likely for each case. So total will be 19 cases. One of them made this is odd factors. The rest will be even factors. So you can see the probability to be odd, just 1 over 19. Okay, so now we go back to our solution. B, 1/19 is our answer.